Hi everyone, welcome to the demonstration of distributed microservices using event-driven architecture paradigm. The framework I'm going to be using for distributed systems development is Molecular.js. It's a Node.js based framework. The folder structure for the framework is on your left side, and one of the most important folders here is the services folder. It contains all the business microservices in the project. So for this demonstration, we will focus on the API gateway microservice, the order microservice, and the payment microservice. Ignore the rest of the microservices for this demonstration. There are some other configuration files in terms of the deployment, and for this demonstration, I'm using Docker Compose as the deployment configuration. There is YAML file for Kubernetes deployment as well, but for this demonstration I'll stick to Docker. And then there is one of this very important file related to the configuration of the framework, and we'll get to this file in a bit. In the meantime, we will also try to start our containers for these microservices, and before we start the containers, we'll make sure they are not already running. As you can see, there is no container that's running at this point in time. And we'll go ahead and start our containers. Now, before this demo, I had already created the container images for each of these microservices. And these images were created basically using those Docker Compose YAML files. And we'll get to that in a moment as well. So this is the container image for API microservice, the payment service instance 1, order service, payment service instance 2, and the NATS server. NATS is the event broker here for inter-service communication in a distributed environment. For local machine deployment, we don't need NATS. You will note that there are two instances of payment service here. This is basically to simulate the load balancing during execution. So we'll start each of these containers here. And while they start, we'll come back here and talk a little bit about this configuration file. Now, as soon as each of the containers loads up, the framework basically generates a service broker on each of these containers as a sidecar service next to the business microservice. And this service broker reads this config file and builds the application runtime accordingly. So as you can see, there are multiple runtime options here. Like, you can choose your own specific logger. For this demonstration, I've just defaulted to console, but there are many other built-in options like Winston, Log4j, Datadog, which are inbuilt in the framework. However, you can also extend this framework if you have a custom logger of your own. You can also specify a transporter. For distributed environment, we need a NAT server or some other type of event broker. For local deployments, this can be specified as null. Then there is an option for cacher. So this could be Redis, Memcache, but for this demonstration, I'm just using the internal memory of the machine that I have here. There is retry policy options for each of the container microservices. Then there are some other health metrics options. There is a load balancer option as well. And for this demonstration, as I said, there will be two instances of payment microservice, and the strategy for load balancing here is round robin, which essentially means that alternate payload will be handled by payment instance 1 and then payment instance 2. There are some other important configurations here related to circuit breaker. These basically specify the threshold So if a container microservice exceeds this threshold, it will be broken out of the circuit. Some other options are here, like performance metrics. I'm using the internal Prometheus one that comes with the framework. There are many other options available, and it can be extended to a custom performance metrics tool as well. And then finally, there is distributed tracing. I'm just defaulting it to console. So each of the microservice, when it runs, will go to the container log and see this distributed tracer also run and give us, stuff like the response time for each microservice, so on and so forth. So this is the molecular config.js file. Now we'll go to the Docker Compose file. As I said, this is where the Docker images were built, and this was already run ahead of this demonstration. So this is the API microservice. This is the payment 1. This is for payment 2, the deployment. This is the Docker deployment for order microservice, and then finally for the NATS server as well. Now, we'll just make sure that all the containers are running here. And we'll also do that here. So as you can see, 5 containers have started running, and these are the 5 that we wanted to run. So service instance 2, payment service instance 2, order service, API gateway, payment service instance 1, and the NAT server. So we are good to go with the execution, but just before that, we'll come back to the business microservices here and just talk a little bit about the functionality that they encapsulate. So this application is going to serve a static HTML on the front end through index.html, and that will carry the API endpoint for this API gateway microservice for payment submission with a specific amount. As soon as the user submits the payment request with this API gateway microservice, it will internally through the service broker route the request to the NAT server, and NATS will load balance that request amongst one of the 2 instances for payment service which are running at any point in time. And we'll see load balancing in action as well. The payment microservice receives the payment request, accepts it, generates an order ID, throws that order ID back to the front end, and also writes it on the console for that payment microservice Docker container log. The message will also contain the node ID, so we will exactly know which instance of this payment microservice has executed that request. Lastly, this payment microservice will also emit an event that order service is already listening to, and this is where the event-driven architecture paradigm comes in, where these microservices are loosely coupled with each other. The order microservice will catch that event and will console to the container log whatever that event message payload is. So we'll see all these things in action now, and we'll go to the front end real quick here. So the front end is running on localhost 3000, and these are the available microservices for this application. Now we'll focus on this third one. We'll ignore the first 2 here. So as you can see, it hits the API gateway that routes it to payment microservices, and within payment microservice there's a endpoint called pay. So we'll hit this, and we get a message that your payment of amount ₹10 is successful using order number 179, and request is handled through broker node ID, and this node ID number is specified. Now first of all, we'll try to find out which payment instance handled this request. So we'll go to our Docker containers which are running here, and we'll try to look at the log for, let's say, instance 1. So as we can see here, that payment instance 1 received this order 179, and payment instance service instance 1 acted upon it, and it's also generating a node ID as well, which it threw back to the front end here. It also must have emitted an event with this order ID 179 that the order microservice must have caught. So we'll go to order microservice and view its log. As we can see here, it says order service caught an event for payment success, and the event details were that your order 179 is successfully submitted. So there you see that payment microservice emitted an event and order microservice was listening for it and it caught it. Now, if I again submit a request and see which microservice instance this time receives the request to find out if load balancing is working or not, let's do that and find that out. So again, this time a new order ID is generated, and as you can see, the node ID is also different. So we'll first try to find out which payment microservice instance executed this request. So this is the log for the payment microservice 1. As you can see, the order ID 65 is not here and it still mentions 179. So we'll go to the container log for the payment microservice instance 2. And we can see here that it actually served this request with order number 65 from the front end, along with this node ID, which is the same as the front end node ID. And again, the order service caught this event, which is for order 65. Previously, it was for order 179, and the recent one is order 65. Now, if I try to keep submitting this request one after the other, you will see that the order numbers will change, since on each request new order number will get generated, but the framework will keep load balancing between these two nodes, which are the two payment microservices. So we'll try to see that as well. And for each request, order microservice will just catch the event and throw it on the console. So this time 979 with 238 node ID. So this is caught by payment microservice 1. Then we'll just refresh the page and alternate it to 94397, which is payment microservice 2 with order ID 832, which is this order ID 832. So essentially, if you just keep your eye on this node ID, if you keep submitting the request, it will keep alternating between these two payment microservices, thereby simulating the load balancing provided by the framework. 943972, 238C248, again 943972, again 238C4283. And each time this request is submitted, the order ID, order microservice keeps catching this event. So let's say the recent one is this 301. We'll go to the order microservice and look at its log and see that it caught the event for 301 order, payment order. So this demonstrates the framework itself for building distributed systems and containerized microservices, and most importantly, the event-driven paradigm through the microservices emitting the events and the other microservices listening for the events and then acting upon it. So this brings us to the end of this demonstration. Thank you for your time.